and welcome to the AI Machine Learning with Rancher Prime demo. In this video, I'll walk you through deploying your AI machine learning platform onto a Dell Apex private cloud environment with Rancher Prime. I'll also show you the difference between utilizing nodes with GPUs and no GPUs, and how to use Kubernetes Customized to automate application deployment. Here we have a basic architecture diagram of the application. Everything is hosted within our APC environment. We have a 3-node RKA2 cluster with Rancher Prime installed, and through Rancher, we deployed a 3-node RKA2 cluster with 1 control plane, 1 GPU worker, and 1 non-GPU worker. This cluster will have KubeFlow and MetalLB installed. We enabled vSAN file services to provide persistent storage to our Kubernetes clusters within this environment. Now before we start, some prerequisites are listed here for you to follow along smoothly, so be sure you're ready going forward. Now then, let's pop into Rancher with our login credentials, and we're going to click on Create and VM vSphere, which will deploy this within vCenter after filling out the necessary information it asks for. First, we name the overall cluster, then we create 3 different pools. The first pool in this case is our control plane. We're also setting the control and workers up with 4 CPUs, about 8 RAM, 40K disk storage, and running it on the Ubuntu template in DHCP network. As you'll notice, we have 1 worker with GPUs and 1 without to compare later. Once deployed, we can see each of these now within our vCenter. And here we are finishing up those last 2 nodes. If you want more information about the details we review here in vSphere, please take a look at the white paper written about this process. Now just a quick rundown of what we see here. Our DHCP network is working to assign IPs to our clusters that we just created. If we were to open up our VMs here and see what they're doing through SSH, we would be able to see that they're installing different Kubernetes components and using them together so that they work as a cluster. This process is sped up here, but we can expect this to take about 5 to 10 minutes to install. Once all of our nodes are up and running, we will manage our cluster through Rancher. In the Repositories tab, we'll add the NVIDIA Container Registry. This registry contains the Helm chart we need to access the GPUs. You need to have valid credentials to authenticate to this registry. Here we go in and modify the code. Now then, in order to install the GPU operator from NVIDIA, we need to run a script that patches the path of container D within RKA2 for version 2 support. Here we're just going to run through the process of how we can do that. Without this modification, the NVIDIA Toolkit container will fail. The script can be found within the NVIDIA documentation, which we're just going to apply here. Feel free to follow along. Now we can deploy the GPU operator, which we will deploy in a new namespace called as such, and then we're going to make modifications to the default Helm chart values. Now then, let's begin with those modifications like I said. First, we ensure the version matches the installed environment within the Kubernetes code. It is set to the latest version by default. For our purposes, we're going to change it to version 470.141.03. This depends entirely on the GPUs in your environment, so be sure to check for that. Next, we define some variables for the toolkit configurations under the environment portion of the code, which you can see here. Once we back out of that, we should see that our GPU operator is running. Now we're going to back out of the workstation terminal, wait for the GPU operator to install as we can see here, and now we're going to run the Customize command to apply files to install KubeFlow and all of its components. At this point, the full GPU deployment is done thanks to NVIDIA taking about 10 minutes to deploy each pod, and that any services that require GPUs are given to them, allowing us to start configuring our platform with Customize. So what we're testing here is all of our pods successfully deploying without failure by running the Customize command, which is written in a loop form to retry installing resources as new ones are available. This loop ends upon success or after 10 attempts. Once deployed, we can see every component that was created and installed, the default being the old KubeFlow components. Now let's jump back into our cluster and search for MetalLB in the Rancher Marketplace. This will allow us to use a range of external IPs to reach our applications outside of the cluster network. Now you just use the default configuration given to us and click Install. Back on our workstation, we need to create a new CRD resource to pass our range of IPs to MetalLB. Now, we can patch the Istio Ingress Gateway service installed with KubeFlow to get a load balancer IP. This new IP will direct us to the KubeFlow UI. Finally, we can reach KubeFlow. The KubeFlow package installs Dex, a Kubernetes authenticator, and we can use the default credentials found in the GitHub documentation. You'll see any deployed notebook in the cluster in the Notebooks tab. It also allows for multiple user logins, allowing your entire team to collaborate. We'll start by creating a new notebook for basic model training. We can specify the notebook as needed. As you can see, we're going to use image with TensorFlow and CUDA with basic CPU and GPU stats. Next, we must create a new empty volume and set it to read write many. This allows multiple users to collaborate on a single notebook. Once we click Launch, it'll be connected to our server. We now have full access to view everything we need to know about image classification and CPU-GPU benchmarking. You'll find everything you need to know about the algorithms your team is testing, written in an easy-to-follow format. We can see it running benchmarking tests below to compare our worker nodes with and without GPUs, as we discussed earlier. Some of the specifications are a little bit different here, however, the results are still roughly the same. After running the notebook, it outputs the read and write runtime as we specified, allowing us to see the comparison between the two nodes. As expected, our worker nodes work much faster with the GPUs enabled, giving us a much faster epoch time. And with that, you can now streamline your AML platform with Dell Apex Private Cloud with Rancher Prime installed, testing and viewing it with a comprehensive interface. Thanks for joining me for a demo on SUSE AML for your APC platform. For more information on how we utilized Rancher Prime with SUSE, check out the white paper that takes a deeper dive into everything we discussed and more.